Expand 1 over 2 minus 5x all squared with the modulus of x less than 2/5 in ascending powers of x up to and including the term in x squared, giving each term as a simplified fraction. Given that the binomial expansion of 2 plus kx over 2 minus 5x squared is this series here, find the value of the constant k and find the value of the constant a. So here's the question in summary form then. Let's have a look at it then. So we need to use the binomial theorem then here for part A. Let's have a go at that. So A, so it's going to be 2 minus 5x to the minus 2. Let's take a 2 outside the bracket. So 2 bracket 1 minus 5x over 2 is what we've got then, haven't we? All to the minus 2. So that's equal to 2 to the minus 2, 1 minus 5x over 2, also to the power minus 2. 2 to the minus 2 is a quarter then. And now we'll use the binomial series expansion here. So we've got 1 plus nx, n is minus 2, times the x value, which is minus 5x over 2, 1 plus nx plus n minus 1, x squared over 2 factorial, and we need only go up to the x squared terms, wasn't it, in the question? Yeah, so plus dot dot dot, close brace. So let's work out what that is then. That's a quarter. The next term will be, the 2's will cancel, the minuses will cancel to make a plus. We've got a 5 and over a 4, haven't we? 5 over 4 x. Next term, 2 minuses, 4 minuses make a plus. This 2 here can cancel with that one there. And then we end up with, okay, so we got 5 squared, 25, times 3. 25 times 3 is 75 x squared over, and there's a 4 here and there's a 2 there, so that makes 8. But it's a 2 squared, it makes 16. Plus dot dot dot. Okay, so that's that done then. So that's the binomial expansion then. And that's provided that where the modulus of x, in our case the x value is minus 5x over 2, is less than 1, i.e. x, bring the 5 over 2 out, is less than 1. So in other words, the modulus of x is less than 2/5, which is what we wanted. Okay, so that's fine, which is what we've shown here. Given that the expansion of this is this, find k and find a. So we've got 2 plus kx times the thing we had above. So part B, here, 2 plus kx times by the squared term underneath is none other than this series here. So let's put it in. 1 quarter plus 5 over 4x plus 75 over 16 x squared, and that's equal to, what do we get on the right hand side? A half plus 7 quarters x, half plus 7 quarters x plus ax squared, wasn't it? Ax squared plus dot dot dot. Okay, that's what we got then. Now we just need part B and C as find k and find a. So let's work this out then. We've got this equation here. So the constant is 2 times a quarter is a half, but the number of x's, so we'll worry about the number of x's now. We've got 2 of these, which is 5 over 2, x coefficient there from that one, and then we've got a k over 4, x coefficient there. And that must equal 7 over 4. So this is 10 over 4, isn't it? So that tells us then If we times everything through by 4, we'll have 10 plus k equals 7. So I just times everything by 4. And that tells us that k is equal to 7. Move the 10 over, minus 10. K is minus 3. Okay, and now let's equate x squareds. So what have we got here then? The x squared terms? Well, we're going to get 75 over 32, aren't we, with the 2 times? So x squareds, 75 over 8, wasn't it? 2 times this will be 8 x squareds. K times 5 over 4 will give us the x squareds here. So 5k over 4 must equal, and then on the other side we've got a x squared, so that's equal to then 75 over 8 plus minus 3 in here, minus 15 over 4, so it's a minus 15 over 4, which you can write as minus 30 over 8, can't we? So that's 45 over 8. So a is 45 over 8, and k equals minus 3.